Okay, welcome back to the class. Okay, now we are going to go into the next topic, which is also the application of planning and scheduling. Okay, previously we look at project smoothing and then leveling. Now the how we can use scheduling to crash a project. Okay, project time cost trade-off. That is the title in being used in some of the books. If you read some of the textbook, then basically they use that title, or in a simpler terminology, we can call it project crashing. Project crashing means to say it is not that is a failed project. It is crashing means to say we compress the project duration, or project expediting, where we expedite the project, okay, for whatever reason. So sometimes we are going to use the word project crashing. So when you hear about the project crashing terminology, it basically refers to we try to compress the overall project duration to the required many amount or whatever according to the client, or even we propose that kind of compression. Okay, we have seen many projects in China, for instance. In China, that they can basically build project in just matter of few hours or few days. But the question is that is the project cost is going to be increased or less or remain the same? That will be the question. Okay. In most situations, people would say when we compress a project, let's say from 2 years become 1.5 year, for instance, the project cost will increase. That is what we normally would associate with. Okay. Is there any possibility that the project cost will be reduced further or remain the same? That will be the situation. So in order to know that, actually we can do some simple exercise. Okay, some simple exercise in order to generate the cost associated with the project duration. But before we go into that, now let's take a look at the concept of project cost, project value, or what we call tender value or contract value. Okay, let me see here. Let's say this is a contract value, or prior to the contract, we call it tender value. Okay, so normally consists of we call it total construction cost. Okay, total construction cost, which we can divide between direct costs, I call it DC, direct costs, and then indirect costs, or IC. Okay, DC and IC. Then on top of that, there is a concept of profit. So that's why in certain negotiated tender, there will be a term that you might have heard, what we call cost plus project. So what does cost plus mean? So cost plus basically refer to this concept. The cost, this is what we call cost, and then plus is design plus profit. So in negotiated tender, basically we utilize the cost plus concept. We need to say all the costs will be paid by the client. On top of that, the contractor will be paid some amount of the profit. But the issue is that how the profit is going to be determined. And there could be many methods. We can call it fixed profit, incline. We can call it targeted profit. We can call it many things. Okay, so all kind of method do have pro and con, but we're not going to that because you will learn those things in construction law or whatever. So direct cost. Direct cost is all the costs related to material, labor, machinery, and equipment directly. This is what we call direct cost. And majority of the costs would basically come from this one. Maybe around 90%. Whereas the indirect costs are associated with the overhead costs. The cost basically to build site office, all kind of utilities, monitoring and controlling could be part of the cost as well. Safety also sometimes being put inside there. So, and then even the cost of headquarters overhead, some portion will basically come from the project costs. So that is the issue. So I would say maybe around 10%. So all the preliminary item would normally will be in the indirect costs. Okay. All right. Now time cost relationship. Tomorrow we are going to look at the cash flow prediction based on scheduling also. Now, you will be introduced to the concept cost again, but this kind of cost will be a little bit different. Okay, this graph, project duration, and then cost of the project. Let's say to certain extreme, let's say in one extreme, let's focus on direct cost first. Okay, direct cost. Direct cost. Let's say direct cost would be around 8 million. The indirect cost would be around 1 million, let's say, and the profit would be another 1 million. So never mind. That would be extreme situation. This could be 2 years. This could be 2 years of the project. But then you compress the project. You compress the project further, and you compress the project. Then basically there is possibility that the direct cost would be reduced. You see, reduce. But then there is a one line here, we call it optimum cost. Okay, optimum cost. Direct cost related to man, machine, and labor, whereas the indirect cost is a straight line because it basically related to the utilities bill, etc. When you have a project much longer, then basically you have to pay more. If your project is basically completed earlier, so basically you don't have to rent the cabin for a longer period of time anymore. So you can see the reduction. Okay, straight line. That is very straightforward. But in the case of direct costs, there is possibility that cost will be going up again. Now, this is another extreme. Let's say from 1 year to 2 year to 1 year. This is the plotting, one year duration of the project, which basically you can see the increase in whatever the direct costs. Okay, in total, so it depends. But the issue is that now let me erase this thing back. What we are, what we are trying to relate to in terms of this graph, the scenario. Okay, let's assume the graph that we are looking at is, we do not have the right hand side of the graph. Let's say we delete this graph. Okay, the total cost is basically a combination of this one and this one. That should be okay. So this line. So we assume the planner is basically creative enough. When they come up with the project scheduling, by right, they should basically come up with the minimum cost, with the least cost. This is what we call the least cost. When you add up direct cost and then indirect cost, so that would be the minimum. We assume that this graph is basically is not there. We assume that will be the assumption. So let's say this is 2 years. The project is running for 2 years. Now you want to compress the project. Let's say this could be 1.5 years. This could be 1.25 years. I don't know. And this could be 1 year. That is the timeline. Okay. So if you want to compress the project from 2 years until 1.5 years, meaning to say 6 months, you compress the project. So there is possibility that the direct cost will be going up. That is what we normally assume, due to the fact that if on the initial stage or on the planning stage, we already come out with the planning at the lowest possible cost because we want to maximize our profit. And for sure, if we want to compress the project, then the direct cost will be increased. Indirect cost is okay because when you compress the project, you are not going to rent, pay bill, etc., etc. But that is not going to be a lot. It is only cost you less than 10%. So when you add the direct cost value with the indirect cost value, for sure, the direct cost value is much bigger than that. So still, the total cost graph will be this kind of what we call curve. So whatever it is, the conclusion is that the cost is going to go up. That is the assumption based on the fact that we assume that our original planning is based on the lowest cost. But if you do not do your planning based on the lowest cost, you can see from what I mentioned originally, there is possibility that you can reduce the cost. Let's say you're still trying to find what could be the lowest possible cost. So you do this kind of exercise, you try to adjust the timing again and again. Maybe this one, you do not have much option as a contractor. Maybe if you are doing some kind of design and build kind of project where you are in control of many things, perhaps you can do that. Okay. If it is open tender where you have no choice, you are given all kind of set of drawing, BQ, etc. Well, most probably, when you want to reduce the project completion or duration, you have to basically increase the cost. Okay, that is what we are going to. The scenario that we are going to use is based on, let's say, this concept. Let's assume that we already planned for the lowest possible cost, and now we want to reduce the overall project duration, and we want to know what is the new cost that we need to pay. And another thing is that how much that we can reduce in terms of timing. That is the what we call project time cost trade-off. What does a time cost trade-off mean? If you want to speed up a project, of course you need to pay more. So this is what we call trade-off. If you want something, you have to let go something. So this is what project time cost trade-off is all about. But in simpler terminology, we can use project crashing. Okay, this is an example. Increase time of the project, meaning to say, if for instance, we prolong the project duration, what happened, of course, the indirect cost will be increased. We need to pay the rent, we need to pay the utilities bill, etc., etc. That is straightforward. How about direct costs? Well, there is a possibility that direct costs also can be increased because just imagine right now, the project has been delayed due to COVID, then suddenly we start all the project, and then suddenly all the construction material price has been going up. That's a big issue right now at the construction industry. See, there could be possibility. Okay. So as a result, the cost could be increased. And if the project is still prolonged, you still have to keep your machinery, manpower, and you still have to pay the project manager, everybody, because you cannot fire them because the project is still not completed yet. Okay, decrease. Let's say you decrease, similar to the what we compress the project. What would happen? Indirect cost is decreased. That would be fine because when you have a shorter period, you don't have to pay rent anymore. Okay, that's fine. But what would happen to the direct cost? The direct cost will increase due to the fact that you need to add more people, you need to bring larger machinery, you need to basically work at night, 3 shifts. So basically you need to even change the construction technique from conventional construction into IBS, and IBS, as you know, still very expensive in Malaysia. We do not have the volume yet. Okay, so at the end of the day, when you have this value plus this value, so you see there is possibility that the project cost will be increased unless you design the project using totally IBS, maybe the one that they have been doing in Forest City. Basically, they use a lot of IBS, and they build the building in volume. Maybe the overall cost would be much cheaper than what the conventional construction would be. That could be possibility. Okay. So now, why basically you need to shorten the project? For what reason? First, client requested the project to be completed ahead of the original schedule. Okay, maybe due to whatever reason. Sometimes as a marketing in a housing project, for instance, sometimes the client will launch phase 1, phase 2, phase 3, phase 4, whatever. And normally as a marketing gimmick, phase 1 would be speed up so that they can sell off the phase 2. When people gain confidence about the project finishing up very early, then you see you get more sales. So in order to make contractor work much faster than usual, of course, you need to basically share your bonus. Let's say you completed the housing development in phase 1 much earlier, then basically you can sell off all your product much earlier, you get all the profit. If, for instance, you are building hotel, the hotel already completed, then you can start operating hotel. Then basically you would generate income already. So as a bonus to the contractor, you can share the potential profit that you are going to gain in order to make contractor work much faster. That would be one possibility. Second, to delay incurred for early activity. Example, delay is a common thing in Malaysia, everywhere in the world. Let's say you already experiencing delay due to whatever reason, then of course you need to catch up, isn't it, for the remaining activity. So remaining activity, if for instance you do not get extension of time or whatever, so the only way that you can catch up with the original project completion is by crashing the later activity. That is the only way. Otherwise, you are not going, because maybe the way you design your activity is really packed. Okay, so you need to basically compress the following activity. Then only you can catch up with the original project completion date. Number 3, contractor getting new job and need to move the machinery and other resources to new site, freeing resources. Let's say you are handling a current project, project A, while waiting to get a new project in project B, C, whatever. Let's say suddenly while still working on project A, you are getting a new project. Okay, so you already have resources at project A, machine, or even maybe a few manpower. Instead of hiring a new machine or getting a new people, why don't you speed up some of the activity in project A so that those machine or some of the people can be released to another project if they're no longer being needed at that particular project. That is the strategy. And then number 4, forecasting for potential adverse weather condition. Okay, now let's say we already know in Malaysia, we only have a few seasons, unlike other country. Other country, they have 4 seasons, isn't it? The only summer they have is 3 months, but we basically have a longer period. we do have a lot of season also. Musim panas, musim hujan, musim kenduri also, season also, musim durian also, many different season. But the season that we are going to that affect our schedule is basically monsoon season lah. Jadi maksudnya in 1 year we can only work in 10 solid month. Maybe 2 months so yang no last time basically at the end of the year is basically very difficult to do work because of rainy season. So you might want to speed up some of the activity so that so that uh, so that maybe you can complete the roof prior to rainy season, and then later on, even during the rainy season, you can still do the internal works because you already completed the roof and etc. etc. So that could be one of the reasons why you need to speed up. Not all the activity, some of the activity. Okay, even though the client might not ask you to do so, but it is for your own sake. And lastly, there could be many other reasons. Just give you a few. Error in purchasing. Excessive material for particular period in order to avoid waste and reduce burden, negative cash flow. Okay, let's say you already purchased material and so when the material are there, maybe you get a cheaper price or whatever, or you buy in bulk and then you bring to the site. Last time it was even worse. When you bring to the site and the material is not being due yet to be installed, you are not going to get anything. Maybe if you can get only very minimum. Right now, they allow you a little bit more. But the clear cut is that if you already use that equipment or install that material in particular activity, for sure you are going to get payment. So in that situation, you will ease the burden of your cash flow. Okay, instead of just bring the material there and waiting to be installed, and it is getting to be stolen or basically rotten due to the weather condition. Why can't you speed up some of the activities so that that material can be used and then subsequently you will get payment? Okay, way to shorten project time. Two ways. Pre-sequence activity. Pre-sequence activity meaning to say you remove all the necessary constraint that you might basically impose during your scheduling. Okay, so maybe you impose certain date, whatever, you're not going to do that and whatnot. So if you remove those things, unnecessary constraint, not all the constraint, unnecessary constraint, then basically you can free a little bit flexible in terms of the timing of the certain activity. And the number two is to accelerate, crash. This is what we are going to do actually. To crash some of the activity so that we can shorten the activity. At the end of the day, perhaps we can basically speed up activity and even shorten the project duration. Shorten the project to some desired duration and at least cost. So you must basically focus on this wording here. Shorten the project to some desired duration. We do not simply shorten the project duration for no reason. There must be reason, because later on when we show you example, then you are going to see sometimes when you choose the wrong activity to be shortened, not only you will increase the cost of the project, but also that activity will not affect the overall project duration. So meaning to say you are wasting your time. So the idea is that we are going to select only a few activities, and normally activity which fall on the critical path. And then we are only going to select activity which basically have a little bit less cost increase. We understand that when you do project crashing, for sure the cost will be increased. That is basically the initial assumption. So we understand the cost will be increased, but we do not want the increase in cost to be beyond our control. Meaning to say, we try to minimize the increase of cost as much as possible. Later on in the example, perhaps you will get this idea. So please remember, the word least cost simply mean that even though when we compress a project, there will be increased cost, but we try as much as possible so that the increase is cost is only marginal or at very minimum. Okay, how to crash activity? Working activity on multiple shifts. This is what certain project has been doing, especially in KL, or even factory is doing that, isn't it? Factory work 3 shifts. Why? Well, when they work 3 shifts, they can produce more. As simple as that. But construction sometimes it's not that easy to work at night, even though you might have spotlight, but again, it's very difficult. Working on extended hours, instead of finishing the job at 6 p.m., maybe you can extend a little bit more, 1 or 2 hours, okay? Bringing larger equipment, instead of using small capacity machine, why don't you bring a bigger equipment and then perhaps it can carry a bigger load? Additional equipment, bring number of equipment, more equipment and more machine, more men. And then lastly, coming out with the alternative design, IBS, for instance, instead of using conventional. But looking at these kind of factor here, for sure there will be increase in costs. So that's how cost increase is almost inevitable. As I mentioned, when we want to compress the project, it looks like bringing larger equipment, we already know. The equipment normally, the rent will be associated with the capacity of the machine, as simple as that. When you bring more people, for sure, you have to pay more. When you work extended hours, for sure, you have to pay more. When you work during the weekend, people don't like it, but still, you still have to pay more. So at the end of the day, you will increase the cost, but you will gain in terms of the timing. So this is what we call time cost trade-off. Okay. In some situation, that is sometimes we cannot avoid. Sometimes we do have a project. Remember last time we do have a project, Commonwealth game and whatever, because we cannot change the date of the Commonwealth game. So a lot of major projects have to be completed on time, such as the stadium, the KLIA airport, and many more. Okay, now let's take a look at example. I want to give you the what we call the relationship between productivity of the labor and duration of the activity. Okay, let's take example of scaffolding. Okay, scaffolding. This is the production capacity. Let's say if we have crew size or gang size, let's say gang size 4. 4 consists of scaffolding, laborer, 2 laborer, carpenter, and 1 carpenter, just example. And this, if we use crew 4 crew, we can produce, this crew can basically install 1,000 square foot of the scaffolding in terms of area. Okay, then if we use a bigger, if we add one more, let's say carpenter, we add just one more carpenter, then basically we can boost the output. Then if we use 6 meaning to say, we increase one more laborer, and then we add one more scaffolding set. Instead of using one, now you can see the production is being boosted much more. And then how about 7? 7 crew, scaffolding 2, we only increase 1 carpenter. And we can see the number of the output capacity is being increased. Okay, so how do we calculate costs? Well, if we already know how many people in the gang there, and we know the salary, hourly rate, or whatever, we can calculate. This is just example, okay? Based on that thing, let's say 84,000. 84,000 is the area of scaffolding that we need to install. This is what we call quantity. And 1,300 is the example of, let's say, this is the productivity. Okay, this is the productivity rate. we use the concept of P, remember, Q divided by T. If we want to find T is the duration here. So that is the equation, okay? So Q divided by P, then we get 64.6 days based on gang number 4. Okay, so this is the example of calculation. Then based on those kind of example, let's say if we use crew number 4, we are going to finish the project in 64.46 days, or we can use even number, let's say 65. And how much is the cost? 33, or if we use 65, this would be the cost. We even out last now. And then if we use crew number 4 and number 5, we are going to complete in 51 days, and then the cost would be reducing. You see, now you can see the cost is reducing. That's why I mentioned to you, there is a possibility. If, for instance, in the initial planning, you do not know how much the cost that it will be if you are planning for whatever thing. If you do the exercise for the first time, you can play around, okay? And you see there is a potential that the cost will be decreased. But then, how about if you use a different crew, 6, then you see that the cost is going to go up again because you use additional scaffolding. And if you use a gang of number 7, and the cost is going to go up again. You see, that is the connection between the method that you use, the resources, and then at the end of the day, you basically know the cost and then the duration, okay, duration of the project. Okay, with this connection here, number of days and then the cost, we can show if this is the situation, it looks like there is a relationship, time and cost relationship that we can equate to. If we can have the relationship, meaning to say we can basically predict if we crash activity, we shorten the project in a lesser time, what would be the cost? If we can know that, that would be good. Okay, and then we can basically do the talking with the client. If the client asks us, okay, I want you to reduce the project in how many days? Okay, now tell me about your cost. Well, you will say to the client, I need to go back and do the calculation. Okay, how do you do that? Perhaps you will do this kind of exercise. Okay, so this relationship is very important because it will tell us about something. The concept of what we call cost slope. Concept of cost slope. So never mind, we are going to go into the next slide anyway. Okay, so this line here looks like the straight line. So this is the straight line relationship between perhaps the four items that we basically show here. But in reality, the relationship is not the straight line. The relationship basically have the curve, this curve. And you notice that this curve is very similar to the one that we mentioned in our slide. You notice this curve? Okay, this is the total cost, this curve. This is the one that basically is equivalent to this kind of relationship. Meaning to say time and cost do have a relationship in terms of the overall project cost and overall project duration. But for academic purposes, sometimes we just assume the relationship is straight line, but in reality, it's going to have this kind of curve, similar to this kind of things. When you have a lot of possibility, let's say you take up the crew, maybe crew number 3, 4, 5, 6, 7, and into so many crew. If you calculate the cost, then basically when you plot a graph, you will notice that the graph will look like a curve relationship. Okay, now we go into the concept of cost slope. So what is the cost slope? So this relationship, the tangent here, okay, indicate a few things. ND, ND is basically normal duration. Let's say if you want to execute a project in a normal duration that we call it practical, okay? Normally, so basically the duration is a little bit longer, so this point, and what would be the cost? We call it normal cost, and normal cost normally it's a little bit low. So if you want to complete something normal duration, and then the cost will be normal cost. But then if you want to compress, let's say you totally compress until you cannot compress anymore, then that is what we call crash duration. And when you want to crash the duration of the project, for sure the cost will be increased. And that cost, ultimately, we call it crash cost. So having said that, at the end of the day, we are going to have this triangle, and this relationship here, this line here, indicate is known as a cost slope. So cost slope is being defined as the differences between costs. You take the highest cost and then minus with the normal cost. So you will get some amount, maybe in terms of RM, divided by the differences in timing. So we'll take the normal cost, which is the whatever the maximum cost, and then the crash cost. So you are going to get whatever value divided by the unit of the time, maybe per day. So you see, RM, whatever RM per day or per week or per month, based on your unit here, this is what we call the relationship of one particular activity. Let's say if you want to reduce the activity duration by 1 day, so you have to add this additional amount. Okay, let's take example. Activity X, one activity. Okay, let's draw something like this. Okay, this is time. This is what we call cost. Okay, activity X is basically normal duration is 10 days. Let's say this is ND equivalent to 10, maybe this point. Okay, can be shortened to minimum limit of uh, 6 days. So meaning to say 6 days is basically the one that we can cut. So the remaining will be 4. So this is what we call crash duration, equivalent to 4. Okay, so based on normal duration, the cost would be the cost of completing would be 6,000. Okay, this normal duration, which basically the cost is not much. Okay, but if we crash the activity, if we want to crash the activity until it become 4 days only, then the cost will be skyrocketed, would be 10,000. And you see, this is the line. We are getting this line, okay? And if we take the triangle here, the cost slope for activity X, we can be defined as, you see, this relationship. So you take the differences between this cost, 10 minus 6,000 divided by this value minus this value, 10 minus 4. You will get 667 per day. And remember, this project originally is supposed to be completed in 10 days. But if you want to crash the cost to the maximum number of days, you can crash until 4 days. But what happens if you only want to crash by 1 day? Meaning to say, instead of 10, you want the project to be completed in 9 days. So the issue is that what would be the cost? What would be the cost? Okay, now, in order to calculate the cost, you already know, by hook or by crook, if you want to complete the activity, this is the cost that you, this is the cost that you need to basically, uh, you need to pay, because you need to pay to man whatever. So the original cost equivalent to 6,000 for 10 days. If you want to reduce the project, to crash the project by additional 1 day, meaning to say you want to complete in 9 days only, so you need to add additional costs. And how much is that additional cost? This is the additional cost. Per day is 667. So meaning to say, if you want to be completed in 9 days, so your cost would be equivalent to RM 6,000 plus 667. So now become 6667. You see, the cost now has been increased. By how much? Based on the cost slope. This is the function of the cost slope. And each of the activity we can define the cost slope, because each activity we can basically know what could be the maximum, the normal time. And then if you want to crash the activity, we can crash until certain time only, but that will be additional cost because we need to pay additional people, etc., etc. So using this kind of concept. So in the academic calculation, if we have all those kind of data, at the end of the day, we can basically calculate the new cost for the project. But this is just for one activity. Many activity would basically have the same concept anyway, but we need to select which activity. Step in project crashing. Okay, step in project crashing, first thing, solve the network diagram. Again, you see, you have to solve the network diagram using AOA or AON or PDM diagram. So as I mentioned to you, this topic is example of the application of planning scheduling. Number 2, calculate the cost slope based on the given information, or if you are well versed with the planning, perhaps you should be able to understand certain activity you can do normally, but then you have basically you can expedite a little bit, but then there is extra cost. Okay. Third, start shortening or crashing by selecting critical activity. That is the keyword, with the least cost slope. Even though each of the activity might have a cost slope, but among the cost slope, one could be more expensive than the other. So if you want to crash the project, first thing first, you must focus on critical activity. Why? Only critical activity will have the direct impact on the project overall duration, because your objective is to reduce the project overall duration, isn't it? So that should be the idea. And then you already know, when you crash a project, for sure you are going to increase the cost, but you are going to increase the cost at the minimum level, in a control manner lah. Kita tak nak the cost will be blotted out. Itu that basically defeat the purpose of doing project shortening. Okay, number 4, shortening process must be done in step by step. Sometimes we call it cycle. Then number 5, look for the formation of second, third critical path. Okay. Normally, in our example, because the project that we show you is only a small number of what we call activity, and it looks like the critical path is only one path, but in reality, it could be multiple paths. So don't get confused. Only in our example, we only show a few of the activity only, so the critical path look very nice, just only one. But in reality, it could be multiple critical paths. So let's say in example that we are going to show you, it looks like we are going to have only one critical path initially. But then subsequently, after we after we do first cycle of shortening, we are going to see the development of new critical path. And then the second cycle, the third cycle, then at the end of the day, all the paths in our network become critical. What does that thing tell you? Well, when you want to crash a project, remember you focus on critical activity. Since all the activity could be critical, and now you have to consider many activity at one time. Not only from the original path, but in many paths. But then you still need to select which one is which. So that is the idea. Then after that, you are going to calculate total cost. Remember, total cost is equivalent to indirect cost plus direct cost. Okay, so direct cost normally we are going to associate with the fixed rate. Let's say how much it is like how much money you spend per month. It is like the fixed cost that you normally spend in your daily expenditure. And that will be the fixed cost. But the direct cost basically related to the activity itself because it is related to man, machine, and then material. Okay, now let's take a look at a simple example first before we go into a bigger example. Okay, this is example of AOA diagram that have three activity: task A, task B, and task C. Only three activity. This one is basically dummy activity, which basically to connect the network diagram. Okay, so the activity duration is given. A is 10 days, B is 9 days, and then C is basically 8 days. If I solve this network diagram, I would say 0 plus 10 equivalent to 10. 0 for B, 0 plus 9 equivalent to 9. 0 plus C is equivalent to 8. So at the end of the day, 10 is coming from A, and it will be the project completion date, and A is the critical path. A is the critical path. So I already identify A as the critical path. This is A critical path. So B and C is not the critical path. So you see, I already solved step number 1. And then next step would be calculate cost slope. Okay. Cost slope is given in this diagram is given like this. So what does this thing mean? 3 at or alias 3 at 100 per day. So remember, cost slope is being defined as how much money per day if we need to reduce in one day. But then activity A can be reduced by 3 days. The maximum that you can reduce is basically 3 days. So we put a note there so that we remember when we do the crashing, we are not going to go over the limit. So similarly, let's say activity B is 75 ringgit, and we can also crash by 3 days, maximum 3 days. And the activity C, it looks like the cheapest. Okay. So now we already completed item number, step number 2. Step number 3, start shortening by selecting critical activity with least cost slope. Okay, let's say my initial normal duration of the project, normal duration, ND equivalent to 10. What would be the normal cost of the project? The normal cost of the project, we must basically calculate how much money, how much cost in order to execute task A, task B, and task C normally. When you add those things, then you will get the normal cost. Let's assume the normal cost is already given. It is like 5,000. Let's say 5,000. Okay, so we already established the original what we call value. Normal cost is 5,000, normal duration is 10. So the cycle number one, let's say cycle number one. Cycle number one, we want to reduce the duration of the day from 10 until 9. 10 until 9, meaning to say we are going to slash by 1 day. 1 day, we are going to crash the project by 1 day. So how are we going to do that? I'm just explaining things step by step so that you understand. In reality, you didn't have to basically do step by step. You just can go straight forward to the question being asked. But I'm just trying to show you the step by step. Okay, if for instance I want to reduce this duration from 10 to 9, what shall I do? That would be the question. Well, take a look at number 3. Start shortening by selecting critical activity with least cost load. Well, it looks like in the cycle number 1, the only critical activity is A. So that is the only activity that we can choose. Even though in step number 3, it also mentioned with least cost load. From the cost load that we already calculate, it looks like C is the least one. Why don't we just simply crash C? But if you crash C, now, for instance, let's say if we crash C, let me slash activity C from 8 become 7. I slash by 1 day and see the impact of what is going to happen to this project. So from the calculation, 0 plus 10 for activity A is still 10. For activity B, 0 plus 9 still 9. For activity C, yes, 0 plus 7, it will be 7. But again, it will not impact the overall project duration. The project duration still remain as a 10-day. You already slash activity C, but you know what happened? You already add the cost to the project by 50 ringgit for no reason. You see, you do not achieve the objective to compress the project at all, but then suddenly you also increase the overall project cost from 5,000. Now you need to add 5,050 ringgit. So that's why you need to take a look at item number 3. When we want to shorten, select the critical activity, and if there could be more critical activity than one, then only we are going to select if there are a lot of activity in that critical path. But in this situation, there is only one. In the subsequent example, you will see another. We can demonstrate it better. Okay, now this is cycle number 1. I mentioned it cycle number 1. So cycle number 1, the only activity that I can basically reduce is basically activity A. See, this is the way I note down. The original activity is 10 days, and then I slash, and then it become 9, meaning to say I slash by 1 day. I reduce by 1 day. And you see, I also slash this in order to indicate the original 3 crashing. Now the remaining is basically 2. Okay, now I do the calculation. 0 plus 9 equivalent to 9. How about B? 0 plus 9 equivalent to 9. How about C? 0 plus 8 equivalent to 8. So it looks like after cycle number 1, activity B now also become critical. This would be after cycle number 1 completed. And this is what the item number 5 is all about. Now we can see the formation of the second critical activity. Instead of only A, now B is now being critical. So next step, let's say we are going to compress the project by another day from 9 until 8. See what is going to happen. Okay, now after we compress activity A by 1 day, we are able to achieve our objective. So the project now completed in 9 days instead of 10 days. But then the additional cost is 100. Why? The additional cost is coming from activity A cost slope. Directly, that is the direct relationship. So what would be the new cost? The new cost would be 5,000 plus 100, 5100. So this is the new cost, and the project basically can be completed in 9 days. So that is an example of project crashing on cycle number 1. Okay, now let's go for cycle number 2. Let's say this is cycle number 2. We want to reduce from 9 until 8. So this is our objective. So since from the first cycle, we already indicate that task A and B is basically critical, you simply cannot just, let's say, B is much cheaper, or you want to decrease the B only by 1 day. You cannot do that, because even though you decrease activity B by 1 day, if you do the calculation, so this is 8, this activity A will be still 9. So you have to reduce both A and B. So in this situation, you have to reduce both A and B, 2 activity, in order to achieve this thing. When you reduce that thing, meaning to say you are going to add another 100 plus 75. So this is 175 additional. And remember, from the previous example, it's basically 100. So you can accumulate those things. So at the end of the day, previous one is basically 100. So 100 total become 275 plus 5,000. 5,000 is the original one. You can do something like this. You can add back, or you can basically add the cumulative. Previously, we already have 5,100. You just simply can add 175. Then you will get 5,275 as a new cost. You can complete in 8 days. That is an example. Okay, now, after cycle number 2, you notice one thing. Task C is also now critical. Meaning to say, if I have the color, the yellow color, I will highlight all A, B, C will be critical, so that I will not miss that thing. Then what would happen if I go for cycle number 3? I want to reduce 1 more days. Let's say just step by step. So if I want to reduce 1 more day, I have no choice other than reducing activity A by 1 day, activity B also by 1 day, and activity C also by 1 day at the same time, concurrently. Then I will do the calculation. I can achieve this thing. By reducing all, then only I can achieve project to be completed in 7 days. But then you need to add additional cost. 100 plus 75 plus 50, that would be 225. Then you add back with the previous one, 5275. Then basically you are going to end up with 5,500 as the new cost, and the project can be completed in 7 days. So now you can see the relationship between when you compress a project, and then you are going to get the new cost and new duration. Well, where are we leading? Well, you know what? If we do that thing, at the end of the day, you are going to see the relationship, something like this for the whole project. This is 10 is basically normal duration. If we can compress until 5, but in our case, we do not do until that one because the limit is shown there only, but never mind. Let's say we can compress until whatever 5. And the purpose is that not for us to compress the project until the end of, we cannot compress anymore, but sometimes the purpose is only meant uh, uh, for us to know what is our limit. And let's say if we would just want to compress between 10 until 8 only, or until 7, then we are going to know what would be the cost. That could be the idea. So from this one, it looks like the line is quite straight, but I can show you a bigger example. Okay, let's say this is another AOA diagram, which basically reflect a much more activity around. And if you do the same exercise, at the end of the day, you see, so the graph that we are looking at, the curve one, this is the same graph that I mentioned to you. The original project, basically 55 days. And the project cost is 38,300, which is not much, normal. But when we reduce, we try to compress the project, you notice that the cost is going to go up and up and up until the end of the project. So let's say you want to negotiate with the client. So you already calculate earlier, 55 days would be 38,000. If you want to reduce to 48 days, what would be the cost? So automatically you know that will be the cost. This is what project compression is all about. Okay, now we are going to take 10 more minute breaks before we go into example. Okay, the rest of the slide basically consists of more example. We do have one example and the last example there. Okay, two more example. Okay, the last one is a little bit longer. Okay, now let's take a 10-minute break before the end of our class. Okay, now let's continue with the rest of the slide. Where is it? Okay, this one. All right. Let's see. We have one example. Okay, one example. Normally, in order to solve this project crashing related question, you need to have data, given data. Okay, in academic concept, the data will be given. So the list of activity is given, and then the normal time or normal duration is given. Normal cost is also given, and then crash time and crash cost is given. So when you have, because without this kind of information, then basically you cannot work on the this kind of exercise. And the predecessor should be given as well. Otherwise, you cannot basically develop a project duration. But the activity connection using AOA diagram is shown there. You can basically develop the network diagram. And then the cost slope. Sometimes the question might not give you the cost slope. You are the one that should calculate. But the cost slope is very easy. How to calculate the cost slope? First thing first. Okay, remember the cost slope definition is the differences between normal costs, the crash cost and normal cost. So you take the bigger cost minus the smaller cost divided by the bigger duration, deduct with the smaller duration. As simple as that. So which one is the bigger cost? For activity 01 is basically 280. So let's put this way, 280 minus 210 divided by, so the biggest duration is 4 minus 3, which is equivalent to 70 per 1. So $70 per 1 day, per days. Okay, so this is the rate for the cost slope for activity 01. So similarly, for all activity, you can do that except activity 35. See, activity 35 cannot be compressed anymore. So no need to compress activity 35 because the data show cannot be compressed anymore. Okay, now that would be the first thing, cost load. The second thing, the normal cost. Remember, when we want to start project, what we call compression, we need to figure out about normal costs. How do you get normal costs? Based on this thing. So the activity, costing for each activity already given. So what you need to do, just you add up all the costs. So this is what we call normal costs. How about the crash cost? When you add up this thing, this is what we call crash cost. This is what we call normal cost. So this basically reflect the extreme. If you want to do the project normally, this is what the cost you should incur. Not much, 3,000. But if you want to compress to the maximum, that will be the cost, 4280. But in terms of the project duration, you simply cannot add up based on this thing. You need to develop network diagram, because network diagram show interrelationship between activity. So that's why you need to come up with the AOA diagram, or whatever diagram you can use, whatever diagram you wish. But in this case, it is given in the form of AOA diagram. Okay, now, so this is what we call early start, early finish date, late start, late finish. Okay, so you do the calculation as what we normally do. At the end of the day, you already know this is the project completion date, and the activity, what we call activity, this is what we call, the one that I highlight is basically critical path. Okay, so the critical path is activity 01, 12, 24, and 45. And what else? What information that we need? Okay, this one. What does this thing mean? Sorry. Let me use the pen. So this information, 70, and then in bracket is 1. What does 70 mean? That is the cost load. The cost load that we already calculate. And what is 1 mean? Here, 1. 1 mean the timing that we can compress. See, 4 minus 3. So meaning to say we can only compress 01 activity by 1 day. So we need to put all the information there, because one, we want to compress a project, then we need to refer to this thing. Okay, that is the first thing. First, you need to establish. Then we can go for next step. Let's say, remember our original normal cost, which is 3050. 3050, normal duration, which is equivalent to 22 days. Let's assume we are going to compress the project step by step. Okay, you don't have to do that, but I'm just showing step by step. We want to compress the project from 22 days into 20 days. Meaning to say, we want, for the first cycle, we are going to compress the project by 2 days only. Okay, from the diagram, you can basically can give a quick answer. If you want to compress the project from 22 days until 20 days, what would be the activity that you are going to crash or compress? Okay. All right. So based on our step-by-step, we have to look at the activity on the critical path. As simple as that. There is no other choice. Even though some of the activity might be cheaper, example, activity number 14, 30 ringgit only, well, we would like to choose that. But if you do the calculation, then there is no, it will not be impact on the number of project duration reduction. So we have no choice to look at the critical path. But on the critical path, there are a lot of activity 01, 12, 24, and 45. So the cheapest one would be activity 12. Okay, now is it possible to crash activity 12 only? Okay, so in order to do this exercise, you need to duplicate many drawing. You have to copy back the drawing because you need to do the calculation and put a rough answer there. Then only you can see. Okay, you cannot just simply use one drawing and then imagine what would be the number. You get confused. So for me, it is better to duplicate the drawing so that you can put some of the notes there. Okay, now let's say this is cycle number 1. Okay, it looks like I choose activity 1, 2. Okay, activity 1, 2. So what happened is that I just slash this one from original 4 days into, 6 days into 4 days because I reduced the activity by 2 days. And then I cannot use this to reduce this activity anymore because the limit is only 2 days. Okay, now I have to do the calculation. So do calculation as usual. This one is 4 plus 4 equivalent to 8. But you have to look at the bottom of the arrow there. Is it which activity basically give the bigger value? It looks like activity 0 plus 8 equivalent to 8. Okay, that should be fine. Then 8 plus 5 here would be 13. How about at the top arrow there? You have to consider all. 4 plus 9 equivalent to 13. Okay, that should be fine. Because sometimes when you crash certain activity, it will not be affected because there are the other interconnecting arrow going into that particular nodes. That will be the issue. So now it is possible to crash activity 1, 2. Okay, now we already have 13. How about activity, go back here, down here, 2, 3. 8 plus 4 equivalent to 12. Okay, that should be fine. 12 plus 13 equivalent to 15, which is not affected. And 13 plus 7 equivalent to 20. Okay, so it looks like we managed to crash this activity, and then we basically achieve 20 days. And how much is the additional cost that we incurred? Well, the additional cost is simple. You just take this value, 50 times 2 days is the amount that you reduce, is equivalent to 100. So this is the additional 100. And remember, the normal cost is 3050. Is it correct? Yeah. So the new cost, you need to add 100. So that will be 3150. And the duration is basically 20 days. So that will be the answer. Okay, now, so that would be cycle number 2. Okay, let's say I want to reduce one more day from 20 into 19. Let's say 19. Okay, from 20 into 19. So just one day. I just want to show, let's say cycle number 2. Okay, now cycle number 2. It looks like I already crashed this activity. I cannot touch it anymore. But then you notice critical path. Critical path now, you see, now this one is critical path. This one is critical path. This one is also critical path. At the bottom, there are also critical path. Oh, there are many critical paths. You see, the critical path, previous one, wait a second. Yeah, now there are many critical paths being developed. Meaning to say you have to consider many things when you want to crash certain activity. Okay, now let's crash, because I only want to crash one day only. So the question is that which activity shall I crash? Okay, scenario number 1. Scenario number 1, shorten one more day. I try to crash this activity. Activity 1.4 and 2.4. Activity 1.4 here, the top there, because it is also critical, and 2.4 here, 2.4, because both basically is the cheapest. Why I cannot crash activity 01. Okay, maybe I can do another option. Do I have another option? Yes. Okay. All right. So if I crash activity 14 and 24, meaning to say in combination, so I managed to crash activity by 1 day, and the cost that I incur is basically 120 ringgit. So 120 ringgit, I add up with the previous cost, I would get 3270. Okay, that would be one scenario. Okay, next, still in cycle number 2, see in cycle number 2, but instead of crashing activity 14 and 24, I now crash activity 45. 45 is here at the back of the network diagram there, because it is much easier when you crash the back activity. Automatically it will be affected. It will basically affect the project overall duration, so you don't have to consider many things. Okay.
Wait, and should I have a question?
Yes.
Why activity 1-2 cannot be crashed more than 2 days?
Activity 1-2. 1-2, the limit is 2 days only.
Why?
Because the question says so. Okay, let's say the assumption is that 1-2, that is the limit as given in the question. Okay, it is like doing concrete work lah. Kadang-kadang in concrete work for floor. So let's say the original duration is 3 days. If you want to compress until 1 day, is it possible or not? Is it something like that lah?
Okay.
All right. Then let's say 4-5. Okay, 4-5. Yeah, you can compress 4-5. So from the calculation, straightforward, you can get 90 days. But then the cost would be 150. Then the new cost is basically 3300. You notice that scenario 1 and scenario 2, the objective is the same. You can compress activity only 1 day, but then you use different combination of activity. But you notice one thing in terms of the cost incurred. For the scenario 1, for instance, 3270. But for scenario 2, basically 3300. So if you need to choose between two scenario, for sure you need the best alternative would be scenario 1, because remember the concept, when we want to increase, when we want to compress the project, we want to compress the project at least cost, meaning to say the increase should be marginal or minimum. We know that there is increase in cost, but we do not want the cost to be extra. For what reason? You have to incur more cost. Okay, that would be the scenario. But there is a trick here. Okay, now this table, later on you can try a few alternatives and see whether you can get the answer or not. Okay, but I'm just telling you how to read this table. Okay, this table tells us the original cost is basically 3050, 22 days. Okay, that is where we start our exercise. Then we reduce to 20 days. What we did basically, we crash activity 1-2. Okay, we crash activity 1-2 by 2 days. We are getting this amount 3150 as my example. Okay, this is the example that we did, exactly the same, 3150. But then the issue is that from 20 to 19, this one, the sample given here is 3260. Whereas what I got is basically in scenario number 1, 3270, and then another alternative is 3300. So the one that this answer is given is much less than my answer. If, for instance, the question simply asks you to crash a course at the least cost, so the right answer will be this. Even my answer would not be accurate. Okay. And you know why basically this example basically giving this answer? Because they use different combination, see, combination of activity. Whereas mine, basically, I just continue from this one and then straight going into another activity. So the combination is not accurate. The methodology is right, but in terms of answering the answer of the least cost, that could be our objective. So both method basically enable us to get what we want, but not the cost. So meaning to say, here, if you look at this diagram, remember in 22 days, we get 3050. Okay, fine. Everybody can get that because that is the starting point. But then 20 days, okay, this is what we get, all right? But when come to 90 days, the answer given is basically 3260, whereas I'm getting, I have two alternative scenario there, 3270 and 33. Okay, 3270 is here, somewhere here. Let's say that 3270 and then 333300. So meaning to say, okay, meaning to say, if let's say 24 of us doing this the same exercise, okay, or in a project, for instance, people are doing the project crashing. Some people maybe could be more creative, looking at all the possible scenario. At the end of the day, he or she could be coming out with the answer with the least possible cost. Whereas somebody, people like me, for instance, because I'm not careful, then basically I'm getting 3270 or even 3300. And you know, there is a range of possibility, maximum and then this minimum. If the question is asking for least cost, the only correct answer is this one. If, for instance, the question is only asking for the what we call the number of days that you can reduce, you already fulfill that, but then a different variation of the cost could be acceptable. But that is not the idea of project crashing, as I mentioned. As much as possible, we would like to control the amount, the increase in the project costs. That is the idea. Okay. So, all right. Now we come into the end of the example. This example. Okay. Let's assume we do have this data. Activity are given. Okay. Except the predecessor is not given. Never mind. We just already have the solution there. Normal duration is given for each activity. Crash duration is also given. And then normal cost and crash cost is also given. Okay, if, for instance, this is the whatever question in the assignment or exam, whatever, for sure, the first step that you need to do is to develop the network diagram. Let's say the network diagram is, we can develop if we already have the, what we call predecessor. For duration, you are going to use this one. This is what you call normal duration. If you have the predecessor, and then at the end of the day, you can use AOA diagram. So you can develop the diagram, and for what reason you are going to get this project duration date, and then the critical path, etc., etc. So that would be the first thing first. Then number two is basically you need to calculate the cost slope, because the cost slope is not given. So how do you calculate the cost slope? Again, I just give you one example for A. So for A, so take the difference between 14, let's say 14,000 minus 12,000 divided by, take the difference between this value, 120 and 100. So that would be 2,000 divided by 20, okay? Divided by 20. So basically you are going to get 100. A basically 100. So that is 100. Okay. So that will be equivalent to 100 per, so this is per day. Okay. And then how many days that you can crash for A? Well, 120 minus 100, meaning to say you can crash maximum 20 days. So those kind of data you need, and you basically put on your drawing. For instance, activity A. Activity A is basically 100 is the cost load, and then you can crash maximum 20 days. Okay, maximum is the 20 day that you can crash. That is what the data is given. Okay. All right. So if you do that, you calculate cost load for each of the activity. Automatically, you will notice something. Among the activity, they could be the cheapest cost load. For instance, activity D is the cheapest one, 60. The second cheapest would be activity A. The third cheapest would be activity E. And the most expensive would be activity C. Okay, now you need to establish the diagram and with all the data before you start your calculation. Okay, in this example, there is another twist. Okay, another twist. Normally, the cost given for each of the activity would be associated with the direct cost. Direct cost only. Direct cost. Okay, because remember, direct cost related to man, machine, and material. And whereas the indirect cost can be considered as a fixed cost because it is part of the preliminary cost, everything. How do you get the fixed cost? Simple. The amount you basically divide back by the total duration of the project, then basically that could be the rate. We simply say it is a fixed cost, even though it might not be the same every day, but for simplicity purposes, normally indirect costs being associated as a fixed cost. Okay, let's assume this is the cost that we have is basically the direct cost. We do have indirect costs given in the question as 50 ringgit per day. So in order to get the total cost for this project, for sure you need to add the indirect cost plus the direct cost. Okay, the next step that you need to do is basically to calculate the total cost for this project. We already know the normal duration. Normal duration is equivalent to this one, 140. What could be the normal cost for this project? So the normal cost for this project now is basically combination of direct cost plus indirect cost. So direct cost, we can get from this cost, normal cost here. So now normal cost basically can be assumed as a direct because we do have the indirect costs being separated, okay, unlike the previous example. So if we add all these costs, this is what we call direct costs, okay, the normal direct costs, but this is just DC, which is equivalent to, I think 48, okay, 48300. So this is what we call the direct cost. Okay, how about indirect costs? So we already have 48300 plus indirect cost. So indirect cost is 50 ringgit per day. If our project will be running for 140, so indirect cost will be 50 times 140, which is equivalent to 7,000. Actually, I already show here. The calculation is here. So this will be 7,000. When you add this value, then you get 55,300. So the normal cost for this project, the overall cost would be 55,300. So that is the first original cost. Normal duration we know for 140, and total cost for this project, inclusive of indirect plus direct costs, would be 55,300. Okay, we need to establish this thing first. Then we are going for the first cycle. The first cycle, let's assume we are going to compress the project by 10 days. From 140, now we want to go for 130. Is it correct? Yeah, step by step. Even though you can compress straightforward, but just go step by step. Okay, now the question is
Doktor, saya nak tanya.
uh-huh.
Yang indirect cost tu maksudnya kita boleh assume berapa je lah kalau macam contoh soalan ni tak ada bagi tahu indirect cost.
Normally kita akan bagi tahu lah sebab we want the answer to be the same, isn't it?
Okay.
We are just going to give you. Okay. All right. Now, let's say next cycle we just want to reduce by 10 days. Okay. So the question is that what activity we are going to compress? So first step, we are going to look at the critical path, and only those activity on the critical path will have the direct influence toward the project overall duration. Yang lain-lain tu tak payah nak consider. Even though dia ada lagi satu consideration, we call it lowest cost load. Tapi dekat sini pun lowest cost load tu within critical path. Also, that should be okay. But then the issue is that which activity? But you need to copy the diagram. Otherwise, it is very difficult to conting lah. Okay, now, well, it looks like the cheapest one will be 60. Yang D will be D. Is it possible? Because there are the interconnection of the activity there, but we need to do the calculation. Then only we can see. Okay, next, crash activity D. This is my choice. And then we do the calculation. Let's say the cycle number 1. Okay, D, focus on this one. So I crash 20 days straight. Okay, 20 days, 10 days. I crash 10 days. That will be the maximum for D. D cannot be crashed anymore in the next cycle. So the original duration of D is basically 30. When I crashed 10 days, so the duration would be 20 days. Okay, based on 20 days, then I do the calculation. Okay, I do the calculation, 60 plus 20 equal to 80. Then tengok pula yang bawah, F. F would be 20 plus 60 would be 80. Okay, should be fine. Then go straight to E. 80 plus 50 equivalent to 130. But look at the A at the top there, whether it's going to be affected or not. So it looks like A is 120. So meaning to say, the biggest value would be from E. So that should be fine. When we compress activity D, so it looks like it is workable. And we are able to compress activity project duration until 130 days. And what would be the project cost? Okay. Okay, project cost is like this. What would be the additional cost? Focus on D. D, we already cut 10 days. Each day will the cost is basically 60 because that is the cost load. Okay, so 10 times 60 equivalent to 600. So 600 is basically the extra cost based on direct cost. But remember also, this is additional, but we also compress the project by 10 days. So meaning to say, this is direct cost, the additional. The indirect cost actually is being reduced by 10 days. So I would say reduce 10. How much is the rate of indirect cost? Is basically 50 ringgit. Kalilah 50, then we are going to have negative 500. So net basically increase in cost. The difference between direct cost increase, okay, but indirect cost decrease due to reduction in timing there. So actually the net is only 100. So this is what we call additional cost. So remember the normal cost that we already calculated before. Let's say total normal cost is basically direct cost plus indirect cost that we mentioned before is equivalent to 555. 300 from the previous slide here. Ini dia, 55, 300. So if the new cost, we just add with the 55, 300. So we are going to get 55, 400. So this is what we call total new cost based on 130 days. This is the example. Okay. So we notice that after we completed cycle number 1, doing the calculation and whatnot, look at the yellow mark there. It looks like the formation of the new critical path. Remember, previous one, critical path, only one line there. But now, F is also become critical. So in that situation, it makes our life more complicated if we want to reduce more, because we need to consider many activity. But that's okay. Now, let's go for cycle number 2. Let's say we want to reduce 10 more days. From 130 into 120. So we know that D cannot be compressed anymore. So what's left is basically B, C, E, F. That will be critical. So which activity are we going to consider? It looks like E is the cheapest one. Okay, E is the cheapest one. Is it possible? Well, from the answer, it looks like I also did crash E. Okay, because E is at the end there. So whatever happened, it should basically affect the project duration. Okay, now let's focus on E. So E is basically completely crashed. It cannot be crashed anymore. And then from 50, put it 40 there. Okay, 40 there. Then we do the calculation. 80 plus 40 is 120. That should be fine. But how about A? Or A is also 120. Okay, that's fine. So it's workable by slashing activity E. So we are able to do that. We don't have to consider any other things. And what would be the cost? Okay, now the cost for E equivalent to 10 times 120, equivalent to 100. How about, that would be the direct cost, additional 1,200. The indirect cost, again, is we are going to minus with 10 days. Meaning to say 10 times 50 equivalent to negative 500. So net increase is basically 700. Is it correct? Yeah, 700 plus 700. So net increase. So you can add 700 with the previous value there, then you will get 56. Okay, 56 100. Okay, so you just add with the, because this is additional cost, so you will get 56 100, and then you can reduce the project by 120 days only. And you notice that after cycle number 2, it looks like all the activity now become critical, but D and E cannot be crashed anymore. So it looks like A, B, C, and F is the only thing left. So what's next? Let's go into next cycle. Okay, next cycle, I just want to crash five days. I can go for 10 days, but I just want to show 5 days, because you know why? Because some of the activity here only limit to 5, but I can go for more. Okay, 5 days. So it looks like I need to crash activity B and A. B and A in one go. Okay, but I need to basically do the calculation. Otherwise, we simply cannot see. So I crash 5 more days. So B cannot be crashed anymore. Okay, that should be fine. And then B is basically 15. So I do the calculation, 0 plus 15 equivalent to 15 here. Then 15 plus, what is this? 40 equivalent to 55. And then 55 plus 20 equivalent to 75. But look at F. 15 plus say 60, also equivalent to 75. That should be fine. 75 plus 40 equivalent to 115, but on the top there, that's why I crash activity A, because otherwise I cannot compress the activity. I need to compress A and B. So when I do that, so automatically they basically equal to 115. This one is also 115. So I am able to crash activity 5 more days, and the additional cost would be equivalent to, there are two activities, A, 5 times 100, which is 500, B, 5 times 200, okay, 1,500 plus, but then I need to minus with 50 times 5, 250. This is what we call indirect costs. So the net would be around 1250, if I'm not mistaken. And when you add with the previous one, 56,100, you would get 57,350. That would be the new cost, and then the project can be compressed 115. Okay, the issue is that we can go for 5 more days, okay, because we cannot compress B anymore, and then D already complete, E, but we can still compress A, C, and then F, okay. Let's go for 5 more days. Cycle number 4. So it looks like, yeah, A and C and F is the only one that we can compress, okay. They are interconnected anyway. So when I do the calculation again, 5 more days, then at the end of the day, I managed to get 110. And then the additional cost, you can calculate, this could be 500 here. This could be 3,000, this is the most expensive. This could be 5 times 3, 1,500. And then you have to deduct with 240, 250. So you should get the 62,100 as the new cost. Okay, the issue is that can we reduce more? Can we reduce more? You notice that C can be reduced 5 more days. A can still reduce because there's still remaining time. Actually, we can do that, but do we? Okay, I do not do those things, but you can try. I think we can go until 105. Okay, 105, and repeating the same crashing here, A, C, and F, and you will get a new cost. That when you do this kind of exercise, this is what we call completely crash a project until there is no more activity that you can crash within the limit. Okay, so maybe 105 is the maximum, but maybe there is a statement that I miss in the concept there. Go back. Where is that? Is it? Okay. I missed this thing. This point here. It is rarely feasible to completely crash either an activity or a project. What does that thing mean? A project meaning to say completely. We do not do that. We do not completely crash everything. It could be very expensive. So we must basically select because there is objective that we want to achieve. Similarly, you are not going to go very far if you just simply crash one activity as we demonstrated, okay? So that's why sometimes we need to combine a few activities together, and normally we are not going to completely crash a project until we cannot crash anymore. But in our example, we just simply show there could be possibility if you are going to do this kind of exercise in the final exam or so, it will take you forever. So that's why normally we just maybe if there is a question for like this, maybe we just simply going to ask you to crash one or two activity only for a few days, just to see how basically you come up with the approach and what could be the final answer that you will get, how many days you will basically able to compress a project, and then what could be the potential new costs. Okay. Project crashing sample question example. If you are given something like this is very simple question. Calculate the cost slope. Well, you take the difference between this, divide the difference between this one, so you will get the cost slope in one of the answer. This example. Okay, in this example, for instance, normal time is given, crash time is given, normal cost. Given the indirect cost, see, the indirect cost is given, calculate total cost of the project. Okay, how are you going to calculate the total cost of the project? You need, first thing, you already know the normal cost. Okay, that will be one thing. This is what we call direct cost. Okay, you already know. But the issue with the indirect cost, you cannot basically time with whatever value here. You need to develop the network diagram. Then only you will know the project duration. Once you know the project duration, then you basically time with this one. Then you are going to know the indirect cost. When you add indirect cost with the direct cost, then you will get total cost. Okay. All right. Then which activity indicate the highest increment in project completion need to be done? Basically, based on your cost slope, you will see which one is the maximum value. That would be the maximum thing. You do not want to choose that. You want, on the other hand, it's basically the least cost slope. Okay. A decision to be made on the activity 4.5 need to be completely, well, basically you need to develop a network diagram as what we showed you before. Then only you try to crash activity, the given activity 4.5, and try to look at the interconnected activity. Then only you know that how many days the project completion will be reduced, and subsequently it might affect the indirect cost. That would be one thing, but the indirect cost you just basically add with the additional cost loop, then basically that will be the answer. Okay. What is this thing? Direct cost activity, determine cost with the least cost slope. Least cost slope means to say once you come up with the cost slope, then basically the one which is the least cost, the minimum cost, that would be the answer. And then this could be the procedure. If you understand the 5-step procedure that I mentioned, you would be able to answer this question. The contractor can decide to shorten project when. This is again, what could be the reason, the factor for the contractor to shorten the project? Okay, based on our theory there, well, basically you can answer. All right, so that would be the concept for the project crashing. So any question from the floor?
Saya ada soalan.
Okay. Yes. Apa soalannya?
Sorry sir. Apa ni yang soalan tadi kan masa example yang pertama tu Imran ada tanya soalan kenapa dia punya crash project tu cuma dua hari je kan. Maksudnya kalau kita nak crash project tu pun kita kena tengok require pada soalan lah. Sama ada dia kena potong berapa banyak je ataupun kena
Yeah, because that is the limit. The limit of bila satu aktiviti itu boleh dikompres. Contoh example lah. Katakanlah kita nak travel daripada JB ke KL. Okay. We can take the long one. Katakanlah kita ambil kereta api lah. Kereta api daripada JB ke KL ni slow, bukan macam kereta api daripada utara tu. Mungkin it will take 6 hours. That will be the maximum time. Tapi kalau misalnya you nak pergi cepat lagi, you mungkin boleh take katakanlah kapal terbang. Mungkin kapal terbang tu 1 hour. That's it, travelling time. Itu dia punya limit dia. Atau katakanlah you nak pergi lagi cepat, setengah jam. Setengah jam boleh tak? Possible tak? Sebab for the time being we do not have the mean to have kereta api laju pun belum siap lagi. Jadi maksudnya itulah yang dimaksudkan dengan limit. Dalam construction pun sama. Certain activity itu if you can do in a normal way, but then you can do in a compressed version. Compressed version itu maksudnya in reality you need to add more working hours. Instead of working from 9 to 5, then you have to work until 7. Then perhaps you can shorten the project daripada 3 hari kepada 1 hari, but itu ialah limit dia. 1 hari, that is limit. Okay, dia tak boleh lagi nak pergi ke setengah hari. Kadang-kadang dia dah tak jadi logik. Itulah maksudnya. Alright. Okay, so any more question? Okay,
Tak ada.
Okay. Let me kejap share the punya attendance. Stop here.